We will present our project about the clinic management system. Overview. Our clinic management system project is focused on making an organized and accurate database to manage the main operations of a medical clinic. These operations include booking patient appointments, keeping track of medical records, managing clinic information, and monitoring the availability of doctors. While doing that, we may face little challenges like overlapping appointments or issues with the manual record. Keeping the database will help make the patient information either to access and more accurate, and that will lead to faster and more dependable healthcare service. I will explain ER diagram. The entity relationship diagram, ER diagram, is used to show the structure of our clinic management system. It includes the main components of the system, entities, their attributes, and how they are related to each other. Entities and their attributes, patient entity. Patient entity represent a patient in the clinic. Attribute, patient ID, primary key. Patient ID, primary key. Full name, composite attribute, first name plus last name. Phone number, multi-valued attribute. Patient can have more than one. Date of birth, occupation. Address, address of composite, street, city, postal code. Note, the age is derived from the date of birth and not stored directly in the database. Doctor entity represents the doctors in the clinic. Attributes: Doctor ID, primary key, full name, phone number, multi-valued, address, composite, department ID, foreign key to department. Appointment entity represents a scheduled meeting between a doctor and patient. Attributes: Appointment ID, primary key, date, time, status, confirmed, cancelled, diagnosis, cost. Patient ID, foreign key, doctor ID, foreign key. Clinic entity represent a clinic or a branch attribute. Clinic ID, primary key, name, address, department ID, foreign key. Department entity represent the department in the clinic. Attribute: Department ID, primary key, department name. Doctor clinic. A bridge table. This table exists because the relationship between doctor and the clinic is many to one. Attribute: Doctor ID, foreign key, clinic ID, foreign key. Relationship explanation. I will explain. Patient box appointment one to many. One patient can book many appointments, but each appointment is for one patient only. Doctor scheduled appointment one to many. One doctor can schedule many appointments, but each appointment is linked to only one doctor. Doctor work in clinic, many to many. A doctor can work in more than one clinic, and a clinic can have more than one doctor. Clinic belongs to department, many to one. Each clinic belongs to one department, but a department can include many clinics. Doctor belongs to department to one. Each doctor is assigned to one department, but a department can have many doctors. I will explain mapping. We converted each entity from the ER diagram into tables in the database. First, every entity like patient, doctor, clinic, appointment, and the department was turned into a table. Each attribute become a column. The patient table includes patient ID as the primary key, name, phone number, date of birth, occupation, and the address split into street, city, and postal code. The doctor table includes doctor ID, name, phone number, address, and also department ID as a foreign key to link it to the department. The appointment table connects the patient and the doctor, so it contains ID, date, time, status. diagnosis, cost, and the foreign case for the patient and the doctor. Clinic has ID name, address, and the department ID as a foreign key. Department is simple and contains ID and the name of the department. There was a many to many relationship between doctor and the clinic. So we created a junction table called Doctor Clinic, which includes two foreign key from doctor and the clinic.
Third step, SQL code. First, I start by making sure there is no previous version of the database using drop database if exist clinic management, create database clinic management, use clinic management. This ensures a fresh start. Then I create and select the database clinic management. I created many tables, like department table. This table stores information about medical departments. Each department has a unique ID and a name. Patient table. This table stores patient information, name, gender, date of birth, address, phone, and job. Sometimes, when we use complex SQL command like triggers, we need to change the statement delimiter for short time. By default, my SQL uses a semicolon to separate commands, but when a command included multiple lines like this trigger, we use delimiter double forward slash to avoid confusion. So, here is what happens. We change the delimiter from semicolon to double forward slash using delimiter double forward slash. Then we write the trigger using begin and end. After the trigger ends, we put double forward slash to mark the end of the full block. Finally, we receive the delimiter back to semicolon with delimiter semicolon. This trigger automatically sets the record date field to today's date every time a new row is added to the medical record table. I then inserted sample data into the department table and added 10 patients. To simulate a change, I updated the address of the first patient. I wrote a query that retrieves doctor information such as doctor ID, first name, last name, specialty, phone number, and address. I also joined it with the department table to show which department each doctor belongs to. This makes it easier to organize the doctor by their specialized. Then I created a query to display clinic details like clinic ID, name, and location. I joined the clinic table with the department tables as well, so we know which department each clinic belongs to. This helps us understand how clinics are structured inside the hospital. I created a more complex query that combines data from the appointment, patient, doctor, and clinic tables. This query shows full appointment details such as appointment ID, patient's first and last name, doctor's first and last name, clinic name, appointment date, start time, and end time, states, diagnosis, and cost. This is one of the most important queries because it gives a full overview of the appointment in one place. Since the appointment query is long and will be used many times, I decided to create a view called VW appointment details. The VW stands for view, which means this is a virtual table. It stores the result of the complex select query. So instead of writing all the joins every time, I can just write select all from VW appointment details. This makes the system more organized, reusable, and efficient.
Fourth step, the bonus GUI. This part of the code creates the main class for the clinic management system inside the constructor. It sets up the main window of the app by giving it a title and a specific size. It also stores the database settings such as the host, username, password, and the database name. The settings will be used later to connect to the MySQL database and manage patient data. This function is called load patients, and this job is to connect to the database, get all patient records, and display them in the app. First, it connects to the database. If the connection is successful, it runs an SQL query to get patient data like name, gender, date of birth, and addresses. It then clears the old data from the table in the add and adds the new patient data one by one. Finally, it's closed the database connection.
Is responsible for adding or updating patient records in the database. First, it checks if the patient is already in the system by looking at patient data. If the patient already exists, it updates their information, like their name, gender, address, and job, using an update statement. If the patient is new, it adds them to the database using an insert statement. It uses %s as placeholders for values, which is a safe way to insert data into the database. This helps protect the system from a common security risk called SQL injection. After the update or insert, it saves the changes using commit, and then it closes the cursor, which is the tool that sends commands to the database. And it also closes the database connection. Closing the connection is important because it keeps the app running smoothly. Next. This function creates the Appointments tab in our application. It builds a table with columns like patient names, doctor names, date, time, and each column is given a size depending on the type of data it takes. It also ensures that the table is added to the screen and fills the whole tab, so users can easily view all the appointment details. Next, this is the part that starts our application, and it starts with the function called main, and inside of it, the first line creates the main window using tk.tk, and it means tkinter, which is the library we used. The second line passes the window into our clinic app, which sets up everything the user sees and interacts with. Finally, root.main loop keeps the window open and running so the user can use the app. And the line if name equal main just makes sure that this only runs when we open the application from the file directly, and not when we import it from somewhere else. Next, and this is the final view for our patient record. And as you can see, it gives you an option for loading the patients, which is getting the patients that are already saved in the database, and add patients, which is adding a new patient that is not already in the database. And as you can see from above, it gives you an option to see the patients, doctors, clinics, appointments, and medical records. Next, doctor records. As you can see, these are the names of all the doctors and all the specialties that can be in the clinic. Next, and this is the clinic's records. Next, and these are the appointment records. And as you can see, it gives you very detailed information about the appointment. About the appointment. Next, this is the medical records. Next, and that was all. Thank you.